In this example, let f of x equal 4x plus 6. Find the input value that goes with an output value of 15. So instead of being given an input value here, you're given an output value of 15. Remember, x stands for the input, f of x stands for the output. So to find the input that produces 15, when you plug it in for x, you've got to replace the output with 15. And then the idea is you solve the equation. So 15 equals 4x plus 6. If you want to work it from the other way around, that's fine. 4x plus 6 equals 15. You can subtract 6 from both sides. If you subtract 6 from both sides, you're going to get 4x equals 9. And you can show that work if you want to. I'm not going to do that here. You get 4x equals 9, and then divide both sides by 4. You get x equals 9/4. So that's the input, such that if you plug it in here, multiply by 4, and then add 6, that's the input you need to produce an output of 15. Next, I want to graph this function on a graphing calculator. It would be easy enough to do by hand, but I want to take this opportunity to show you the graphing calculator and how convenient it is to use, especially to graph, well, perhaps more complicated functions than the one we're looking at. So this is an emulation of the TI-84 Plus graphing calculator. I'm going to go ahead and graph this function. Go to y equals, and I'm going to erase what's there. If there's anything there, just hit clear. And under y1, I'm going to type in 4x plus 6. So 4, okay, x would be given by this button, and then plus 6. And then I'm going to graph this thing on a standard screen. That's zoom number 6. The standard screen goes from -10 to 10 on both axes. So zoom number 6 on the keypad, and that's going to be a little hard to see, so let me show you a separate screen here. So here's your graph. How can we view the input and the output on this graph? Well, this standard screen only goes from -10 to 10 on the horizontal axis and from -10 to 10 on the vertical axis. So we're not going to see, I mean, we can see the input 9/4, which is 2.25, 2 1/4, but we won't see the output, which is 15, unless we make some adjustments. So go to Window, and we've got to stretch the Y maximum. You see the X min, we don't need to adjust that. The X maximum, we don't need to adjust that. The X, that SCL stands for scale, we don't need to adjust that. But we do need to adjust the Y maximum if we want to see our output on the graph. So let's go down to Y max, and I don't want to change it to 15. I want a little bit of wiggle room. So how about let's change it to 20. And let's go by 2s. Y SCL, that's the Y scale. Let's go by 2s. Now let's hit graph. And if we go over 9/4, then a little over 2, we should be up around 15. So let's do this. Let's hit trace, and then that's going to allow you to input into the calculator your actual input. So let's plug in 9/4, 9 divided by 4 for x, hit enter, and you'll see the output is 15. So you know how to define a function using a set of ordered pairs, inputs and outputs. You know how to define a function using an equation, and of course you know how to define a function using a graph. And I just want you to realize that they're all equivalent definitions.